Hello students, and welcome to our continuing series of videos here on series. And in this video we'll talk about summation or sigma notation, and I'll kind of define it and use an example at the same time. So we start out with this symbol here. This is called sigma. This is a Greek letter. Okay. We have some variable k, and we call this the iterator. So this is the iterator, or the variable that we use to make substitutions. And then we're going to have this number here, which happens to be 1. It usually is 1, but it doesn't have to be. And we call this is the starting term. And then we also have some number that goes above the sigma symbol. And in this case, I'll just use 5. This is the last or the ending term. And finally, we have some expression here. And I'll make something up here. We'll just use 2k as our example. And this is the explicit definition or the explicit rule of the sequence. So what this expression is saying is take 1, plug it in for k, you'll get a number. 2. Then take 2, put it in for k, you get another number. Take 3, put in for k, you get a number. Take 4, put it in for k, you get a number. Take 5, put it in for k, you get a number. And stop at 5. Okay. So, and by the way, this iterator, they're always integers. So let's see what happens, right, when we take this and we actually make substitutions. Well, when you take 1 and you put in for k, you get 2 times 1. When you take 2 and you put in for k, you get 2 times 2. Then 2 times 3. Then 2 times 4. And then 2 times 5. And I think when you add all this up, you should get 30. Sorry, my marker's dying out on me here, so let me use a different one. So when you add all this up, you should get 30. Okay. But more importantly, it's paying attention to what this sequence is doing, this series is doing. It's just taking this iterator, substituting it in for the variable, and then just continuing to increase. Iterate means to move forward. Okay? And we know to stop at the 5th term here because of the number that's on top. So let's take a look at a couple examples here so that we can get a better understanding. Okay? So let's write these things in summation notation. So let's write this first sequence here: 1 plus 6 plus 11 plus 16, all the way up to 1,436. And we're not asked to evaluate anything at this point. We just want to write this in summation or sigma notation. And so we'll start out at k equals 1. And we don't know what term this is to stop. We don't know what the last term is. Now, it would be a very big mistake to put 1436 here, because we're not adding 1,436 terms. We're adding some number of terms, of which 1436 happens to be the last one. So the next thing we need to do here is to find the explicit definition or the explicit rule. So as a side note here, remember that the explicit definition is a sub k equals, and in previous examples we've used n. Well, we can use k now, no problem. A sub k is equal to the first term. Okay? And if you notice here, this is an arithmetic sequence. 1, 6, 11, 16, they're all increasing by 5. So we're adding 5 n minus, or k minus 1 times rather. Okay? And so, but a sub 1 happens to be 1. So a sub k is equal to 1 plus 5k minus 1. Okay? And so we can also just simplify this, distribute this. 1 plus 5k minus 5 Altogether, you get 5k minus 4. Now, these two expressions here and here are both correct. When I put it in the series, sometimes I'll put the final one, but it's really important that you're able to get this expression here, what this really means. Go back and look at the notes on section 9.4 if you're in Mr. Wen's class. Look at the notes on sequences to see where this really comes from. Okay? And if you understand where this comes from, everything else from there should go rather smoothly. Now finally, we need to figure out how many terms. We need to figure out how many terms is this. Well, 1436 is equal to 1 plus 5k minus 1. Okay. In other words, the first term is 1, but the last term is 1436, but we don't know how many terms that is. So if we solve this equation here, we'll get 1436 equals 5k minus 4. 1440 over 5 equals k. So k is equal to 288. Okay. So in this case, what goes on top here is 288. So we're adding up 288 terms, starting from 1, and this is the 288th term. So you got to be very careful what these variables and what these subscripts mean. It can be a bit confusing, and it's really easy to get lost in them. Now let's look at another example. This is a series that has 1 plus 1/2 plus 1/4 plus 1/8 plus 1/16 and so on, and this seems like it goes on forever. Okay? So we'll make our summation notation. And we can see here that we say that k starts out at 1, and because it goes on forever, the top here is going to be infinity. Okay. And now what we need that goes in here is an explicit definition. Well, if you look at this is 1, 1/2, 1/4, 1/8. So this is a geometric series or sequence that has a common ratio of 1/2. Okay, so this is geometric, and it has a common ratio of 1/2. You can see each of these terms is 1/2 of the previous term. So if you recall, a sub n is equal to the first term times the ratio raised to the n minus 1. Okay. Again, look back in your notes on sequences and see where this math comes from. I'm just going to apply it here. So the first term is 1. The common ratio is 1/2. Okay. And I use n here, I use k here, so I just got to make sure I use the right variable. So this is just 1/2 times k to 1/2 raised to the k minus first power. Okay. Now to show you kind of the nice thing about series is that I can also rewrite this way. K equals 0, effectively subtracting 1 from here, and then adding 1 to the exponent. Okay, and these two expressions are actually equivalent. And to prove this to yourself, you should, this is kind of a bit of a homework for you. To prove this to yourself, see if this is true. What's the first term of the left-hand side compared to the first term of the right-hand side? What's the second term of the left-hand side compared to the second term of the right-hand side? And compare these two and make sure that you really do come up with the same thing and you really understand why this works. I'm going to do something a little bit frustrating. I'm going to leave it here and let you kind of figure this part out on your own. You should ask, your teacher for help if this doesn't quite make sense yet. But hopefully you get a better sense of summation notation and how this is all related to series. And this is really just a more compact form of writing series. So I'll end this video here. Again, continue working on this. Always ask for help if you have any questions. Make sure you watch the rest of the videos and have a wonderful day.